start talking about the warm-up. So on number 1, one of the largest crimes that you could commit in math is to cancel things out over addition and subtraction. So what I mean by that is one of the hugest offenses you could do would be like to try to cancel those x squareds or something like that. Misdemeanor, yeah. Please never, ever, ever cancel something out in a fraction when addition or subtraction is involved. You have to remember your order of operations. You have to remember your PEMDAS. Okay, so what's really important on number 1 is that first we switch that. We don't want it to be subtraction. We want it to be multiplication. And how do you change x squared minus x minus 56 into multiplication? Well, you factor it. Very good, Abbas. Yep, we have to factor it. We don't have a choice. So let's do it. So we need things that multiply to get 56 and combine to get 1. Very good, 7 and 8. X, 7, 8. We want it to be a negative 56 and we want it to be a negative 1. So we want the larger number to be negative. That's how we're going to achieve our negative 1. And what about the bottom there? The bottom I kind of see as a 2-step one. First we could pull out a 2. You see that? We pull out a 2 first, and then, does anyone know what that's called? How come none of y'all plugged in your cameras? Do you know what x squared minus 49 is called? It's called something. I bet y'all know it. Ooh, yeah, they're perfect squares, but that in parentheses is called, maybe, thank you, Chloe, a prime meridian. Oh my gosh. No, it's called a difference of squares. It's called a difference of squares. Maybe that's an algebra 2 thing. I don't know. Okay, so we've got 2, and then I just know how to factor a difference of squares. It's plus or minus 7, like that. Because 7 times 7 is 49, and then I'll make sure you don't have a middle term because they'll cancel out. It's called a difference of squares. Plus and minus 7. Okay, I know you've learned it. Yeah, you have. Okay, so now we are allowed to cancel because on the top it's multiplication and in the denominator it's multiplication. So we are allowed to cancel things now. It's not illegal anymore. So do you see any things that are equivalent in the top and the bottom? Of course you do. X plus 7, X plus 7. So on number 1, we have simplified it. What are we left with? X minus 8 in the numerator. And you can put 2x minus 7 in the denominator, or you could put 2x minus 14. I would be okay with either one of those. You've canceled out everything you can cancel, so I'm good with any of those, okay? Questions about number 1. We factored and then we canceled. Factor, cancel. So number 1, the instructions were to simplify. Number 2, the instructions are to solve for x. On this one, I'm going to capture it to a new page so that we have room. Maybe you've already solved it. If so, good job. We had one like this in our notes yesterday, but this one has a little secret. It's better than yesterday's, okay? So, cross multiply, that's how you solve. We're not simplifying, we're solving. It's different, and so we're going to cross multiply to start with. X times x is x squared. This one's the tricky one. I'm going to write the middle step, although if you want to skip this step, you're welcome to. The biggest mistake people make is that they forget to FOIL. They forget to FOIL, so make sure you do FOIL. So x squared equals x squared minus 2x plus 3x minus 6. That okay with you? Here's what I love about this problem. Do you know what I love about it? Look at the left and look at the right. Yeah! There's an x squared in both sides. Hallelujah. So Let's clean it. I'll clean it up first before I cancel them out. I won't get ahead of myself. So 3 minus 2, so that's just x. Oh, this is awesome. These cancel. We'll add 6 to both sides, and voila, 6 equals x. That was not as bad as yesterday when we had to FOIL and factor. You nailed it. Good job. It was quite a lengthy homework last night, wasn't it? So hopefully you just did a little bit from each section to make sure, okay, I've mastered this concept, now I'll move on to the next one. Try if you have mastered this, now I'll move on to the next one. So go ahead and check your answers and we will go over whichever ones we need to. We don't have a very long lesson today, so we can spend some time going over homework answers if you would like to. Second page of ratio and proportions answers. Today's homework will not be as long, I promised. If you've already seen it, it's just a front, there's no back. It's a legal page, but there's no back at least. So are you making little notes about the ones you want me to work? It's rounding to 100, hilarious. Okay, here's number 6. It says, sorry to make that so large, 2x over 5x. Do you see any addition or subtraction? No. So that means we are allowed to cancel things. Now, what is 2 over 5 reduced to? Well, it doesn't reduce at all. It doesn't simplify. 2 over 5 is 2 over 5. What is x over x reduced to? Well, the x's cancel. When you find something in the numerator that's identical to something in the denominator, it cancels. So that changes to 1. X divided by x is just 1. Do you need to write the 1? No, you don't. So that's why the answer to number 6 is 2/5. What else can I work? 37 is our classic example of cross multiplying. So you can do the middle step or you can skip the middle step completely. We're going to do 45 times 16 divided by 15. 45 times 16, enter, divided by 15, enter on your calculator. And you're going to get x equals 48. Now if you want to show your work and you want to do the middle step, then you can write out 45 times 16 equals 15 times x. And then you would, of course, multiply that side, and you would divide both sides by 15. So in essence, you're doing what I said to start with, okay? So you can cross multiply and divide, or you can show that middle step and you can cross multiply and put that equal sign, but you'll end up dividing in the end. So today is called Ratio and Proportions Day 2. So what we're going to do is take our knowledge of fractions and ratios and proportions, and we're going to use it to solve word problems. So real world applicable problems, applicable problems that we can apply to the real world. Let's look at it. In the model of a building, the height is 10 inches and the height of the actual building is 280 feet. If the width of the model is 12 inches, then what is the width of the actual building in feet? So this is something that my husband deals with every day. He's an architect and he works with models, and then he works with the real size and the scales and the scale factor, which we'll talk more about in a couple days. But for this problem right here, all we need to know is how to set up a proportion and then how to cross multiply. So there's two choices here. You can put the height of the model over the height of the building equals the width of the model over the width of the building. Height over height equals width over width. Or you could put inches over inches equals feet over feet and keep the model on one side and the actual building on the other. Totally up to you. I like to do height over height equals width over width. So that's what I'm going to model up here, but you're welcome to do it your way if you would like. So let's see. The height of the model is 10 inches. The height of the actual building is 280 feet. Height over height equals width over width. Now, a lot of people ask, do we need to convert these? Do I need to convert all the units to feet? What do you think the answer is? Do we need to do conversions? Oh. Yes, no, and maybe. Awesome answers, guys. Now, yesterday we did a conversion because I told you to simplify a ratio. And the top was in yards and the bottom was in feet. And it was necessary because we're comparing those two things and we're simplifying it. This one, we're solving for x. Now, if I cross multiply and I do 12 inches times 280 feet divided by 10 inches, what's going to be left over? The inches are going to cancel and feet is going to be left over. Do we want our answer to be in feet? The width of the actual building? Yeah, we want our answer to be in feet. So the inches are going to cancel and we're going to be left with feet. That's what we want to happen, so no conversions necessary. Do not convert when you're doing proportions. When you're just doing a ratio, you have to convert. When you're doing proportions, you usually do not have to convert. So let's cross multiply. 12 times 280 divided by 10. Chloe, what do you get? 336 feet. Always put units when we're doing these word problems. Very good, Chloe, thank you. Like I said, look and see if it makes sense. Okay, 12 is bigger than 10, a little bit bigger, so our answer better be bigger than 280, and it better be reasonable. It better not be a ton bigger, just scale-wise a little bit bigger, and it is, so that's perfect. Let's keep going. Number 2. Marta is making a scale drawing of her bedroom. Her rectangular room is 12 feet by 15 feet. On the scale, the width of her room is 5. What is the length? So same problem, different situation. So if we're going to do like we did last time, we want to keep width over width equals length over length. We want to keep the types together. So 12 feet wide, and the width is 5 inches. So I'm going to put 12 feet is to 5 inches as 15 feet is to I don't know how many inches. So same thing as last time. Make sure you keep your feet. Make sure if one of them is in the numerator, the other one's in the numerator. All right, Edriel, cross multiply and tell me what you get. Rishi, you can totally do 12 is to 15 as 5 is to x. There are, I don't even know how many ways. There's at least 3 ways that you can set up this proportion. At least 3 ways. So I'm going to be consistent, and I'm going to do it the same way every time. I'm going to keep width over width, height over height. Width over width, length over length. But if you want to set it up a different way, you can totally do that as long as it comes out to the same answer. Okay, very good. So 6.25, or as a fraction, 25/4. They're both acceptable, but you do need to put your units, inches, inches. Since the problem didn't tell us what to round to, both of those are equally acceptable, okay? Moving on. Ooh, this one's fun. The ratio of a bunk bed's weight to the weight it can bear, like the weight it can hold, is 3 to 13. Its weight to the weight it can hold. How many 40-pound children can a 65-pound bed hold? So someone's having a sleepover, and they're inviting all their friends. We're talking little kids here. And we want to know how many friends are allowed to get up on that bunk bed while they're having a pillow fight or something. I don't know. So go ahead and see if you can get this one. Don't type the answer in the chat yet. Okay, let's talk about this one. Thank you, Alton, for answering. Okay, the bunk bed's weight to the weight it can bear. So that's the bunk bed's weight, and this is like how much it can hold. So 3 to 13. Now, how many 40-pound children, we're going to save this. We're going to save that information. Can a 65-pound bed hold? Well, the 65 pounds, that's the weight of the bed. So we want to put it where the weight of the bed goes. So the weight of the bed to the weight it can hold. When we get x, that's going to tell us how much it can hold. So we're going to cross multiply 13 times 65 divided by 3. And we get 281.6 repeating. It cannot hold 281 kids. That's how many pounds it can hold. Each kid is 40 pounds about. That's their average. So we're going to see how many 40-pound kids can hang out on this bunk bed. So we're going to divide it by 40, and we get 7.0416 repeating. So we're not going to put 7.04 kids because you can't have a 0.04th of a kid, right? So we want to be careful that on this problem we never round up, okay? The answer is 7 children. You were right. But even if our answer, let's pretend our answer would have been 7.8. When we divide it, we get 7.8. You cannot say that 8 kids can fit or it can hold 8 kids. That bunk bed will fall. It will break because you have to round down on a problem like this. This is a real world problem, so you have to make sure you know the context and make sure you never round up, because if you put that 8th kid on there, it's over. Okay? Or all those pillows. Yeah, you're right. Okay, so I hope you're okay with that. Revisit that one at home if that one was trouble for you. Couple more left. The ratio of the side lengths of a triangle is 4 to 7 to 5. Its perimeter is 96. What is the length of the shortest side? So remember how to solve this problem? 4x plus 7x plus 5x equals 96. In total, there are, what, 16 parts? So you're trying to find that common ratio? Nope. That's fine. That's why we're going to work it out together. So 96 divided by 16 will get us 6. We know that x is 6. And then we want to plug it in, and all we care about is the shortest side. So 6 times 4. We okay with that? That's okay. 24 is the answer. That is the shortest side. All right, 2 more problems. Stay with me for 2 more. If you have to go to your next class, go to your next class. You are baking 4 dozen. How many is that? 4 dozen. 48. You're baking 48 large cookies for a party. You need half a cup of mixture for each cookie. The recipe calls for cookie dough, chocolate chips, and walnuts in the ratio of 6 to 3 to 1. How many cups of each ingredient do you need? This is making me hungry. Makes me want to go home and bake cookies. All right, guys, real world problem. Here we go. See what you can come up with. I'll give you some time. I'll stop talking. So how we want to look at this first is, what I did first was 4 dozen. I changed that. Okay, so that's 48. Making 48 cookies. But for each cookie, we need half a cup of mixture. So for how many cups of mixture do we need? Yeah, those are good. So we need 24 cups. Very good. We don't need 48 cups. That would be a lot of cookies. We need 24 cups of mixture, okay? So we're going to have 24 cups of mixture. We need an S there. So now we do that thing where we attach an X to it. 6x plus 3x plus 1x equals 24. 10x equals 24. X is 2.4. So about 2.5 cups of each well, not of each thing, that's our ratio. So let's do the walnuts first. The walnuts has a ratio of 1. So we need 2.4 cups of walnuts. What about of chocolate chips? Well, that has a ratio of 3. So we're going to do 3 times 2.4. Like right here, plug 2.4 in. 3 times 2.4, 7.2 cups. And then we've got our cookie dough. We need 6 parts cookie dough. We need 6 times 2.4 of the cookie dough. So 14.4 cups of the dough. Another one that you might want to look at home. You got it? Okay. Go ahead and go if you need to. You go into Italy. You bring $300 and you say, hey, give me some euros. How many are they going to hand you? Brisha, you've already gotten it? So I would recommend setting up a proportion, or you can just use 1.33 kind of as a scale factor, even though we haven't really talked about that yet. So you could say it's 1.33 US dollars for 1 euro. So you could say 1.33 dollars for 1, is that the symbol for euro? I actually don't remember. So dollars is to euros as dollars is to euros. You could set up a proportion. If you don't know whether to multiply or divide, you could set up a proportion. So yeah, it's 300 times 1, which is 300, divided by 1.33. My cursor keeps getting in the way. All right? So you are taking with you 225 euros.